Hi everybody, I hope you guys can see my screen. Like John said, I'm going to be presenting on Whitewater and WaterWall system. My name is Noah Morgenstern and I am the Director of Marketing for North America and South America. To just give you a very brief introduction about Whitewater, we are a leading technology provider of smart water network monitoring and management software solutions. So what we mean by the smart water network are those data-driven components that sit on top of the physical infrastructure that will allow the physical infrastructure to see increased reliability, efficiency, and longevity. Mainly we're talking about sensoring systems and telemetry, data infrastructure and displays, and data fusion or analytical technologies. And in Whitewater, we focus on three very important aspects. The first being analytics, the second being integrated management, and that's what we'll speak to a bit later, and last being optimization. And ultimately, these technologies are used to increase operational efficiency. The idea being that we see one of the strongest needs is to free up available capital to be used for capital improvement programs, for replacements or rehab or increased capacity projects. And we see the technology being a strong enabler of this reduction in the operating budget. So I'm going to jump right in. I hope you guys can see the screen right now. You're looking at a few of the interfaces of our WaterWall system, which is our water network management platform. Very basically, the WaterWall is a management and operational software solution that integrates data from throughout the utility, correlating relationships between those data points to create that information, and it follows business processes and procedures to prioritize tasks, very similar to what John brought up earlier when he was talking about business processes and sitting everybody around the table. Utilizing this information, we're able to configure the WaterWall to seamlessly enable these functions to take place. And ultimately, like you said, with the workflow software, we can automatically guide the response in the form of digital standard operating procedures that can either be semi-automatic or fully automatic to reduce those type of human errors and actually guide or standardize the process. And ultimately, the system visualizes what is happening on a GIS viewer. Now, I'd like to jump in to our first scenario. And I'm going to go over three scenarios that I feel are very strong points towards the ability to increase communications towards that exiting that silo. And the first one is going to be around water network analytics. And what you can see here is that middle symbol is we're going to think of as the WaterWall server, the WaterWall platform. What we're going to be looking at is increasing communications between four groups, mainly at first our water quality team. Next, our vertical asset operations or production team. Our linear asset operations, so our distribution team. And then our maintenance team. And ultimately, the systems that we're looking at within this scenario are going to be the laboratory information system, the LIMS, which is holding the time series data from sampling, the SCADA system, which is the control and acquisition system. This can be both part of the production team and the distribution team. The sensors that are both in the vertical assets in the treatment plant, as well as those operational sensors, be it flow or pressure or level sensors, to water quality sensors in the distribution system, as well as those work orders that are coming from a CMMS system or other type of work order management system. So ultimately, we're going to be integrating information from the water quality team, mainly focusing on laboratory data. And for example, if they are the main primary responsibility of water quality sensor data, from the production team, focusing on various pieces of SCADA information and selective tags, and that would be defined by the information that we do want to analyze. that information from the distribution team. Again, if we're taking online data from operational sensors, if we're looking at valve, pump, or tank operations, or simply looking at online water quality information. And what we're going to be doing is utilizing an application that sits on the WaterWall platform called our Water Analytics System, which is able to integrate the time series data, the data from SCADA, as well as the online sensor data to provide in real time an understanding of if water quality is changing, abnormalities in the distribution system, and operational abnormalities. As well, it will provide information on how operational changes from the production facility through the distribution system are affecting water quality. So it is very important to be able to share this information between these three groups. So ultimately, what the WaterWall is able to do is provide a visualization of both real-time multi-parameter interactive data, as well as event logs for anomaly detection, to all three of these groups who are trying to communicate or improve the communication between. The most important aspect of this scenario is that if there is a water quality anomaly, we're going to want to check what is causing that water quality anomaly. And having the production and the distribution team looking at the results as well will be able to inform all the teams if there is some sort of operational change going on and being able to confirm what it is that's causing that water quality change. Or on the flip side, if there's an operational change, if they'd like to see if that operational change has affected water quality, either on the sampling or in the real-time data. What this enables the teams to do is ultimately generate work orders by defining an alert from this analytics system, which will be pushed back into the WaterWall server and ultimately exchange information with the CMMS system, either creating and initiating a work order and grabbing the work order number and then proceeding into the workflow management aspect. And that's scenario one. Next, I'd like to go into the unified reporting. Again, this is a subject that John touched on as well, and I think it's one of the single most important aspects of one of these WaterWall deployments. And you'll see that there are many aspects or many areas where data can be entered. The first that you see on your screen is from discrete data from the business systems. This can be from, like John said, your ERP system, from your billing software. It can be in your CMMS system. Any one of these acronyms, as soon as you enter in information and hit submit, this is a piece of discrete data. And this information is being fed into the WaterWall. Now, the most important aspect for manually entered data is to be able to map this data. We know when we enter a lot of utilities that, like John said, there are multiple points of entry of possibly the same data. So it gets entered duplicitously, and sometimes, like he said, there could be a transformation or error in the syntax of the entered data, which causes reporting or automated systems that are relying on this information, or even trending software that's relying on this information to provide poor results. So what we're trying to do is look at Excel sheets, Microsoft Access tables, clipboards, even Post-it notes, and try to understand where data is held. What we then want to do is understand what is that data being entered, and customize digital forms to replace those areas where data was manually entered. And to do this, the most important aspect of any project is that first discovery or business assessment session, like John was talking about, with the business processes and procedures and the data mapping. Looking at what data is coming from where it's originating from, where you would like to have it go, and then how you would like to have it be reported upon, and who would be able to see that data. From here, we want to define all those reports, and from there, with that definition, we go and customize those forms. So ultimately, once that data that used to be held in those fragmented systems is now being unified and centralized in the WaterWall together with the data from the business systems. What this allows you to do is then, by a single mouse click, create reports. And this is where the business intelligence comes in. So as part of that data mapping, it's important to understand the types of reports and the type of information, whether it be for compliance, for discharge permits, for disinfection reports, whether you have a key performance indicator report that you'd like to look on within the production facility and the distribution team, or on the managerial side if you want to look at costing. We can define these together with the utility and create those templates, so when you do click on that mouse, it'll be automatically populated and pushed into either a dashboard or a report that can be sent from PDF or exported if necessary. The last scenario that I'd like to go in that I think shows this silo effect very well is what we call geo-processing. And this is focusing mainly on customer calls or customer service. So when a customer calls in, once customer entry information is put into the system, we're going to be focusing on an area where the location of that call is coming from. So when we're looking at the address, we're able to do a geo lookup. And what is a geo lookup? It takes into account a process that was developed by defining a radius, a specific distance around that geolocation or that address, to look into if any other information could be provided to that customer service agent or could be provided out to the field that would indicate other work in the area that would give a larger picture, a holistic view of the operations in that service area. So taking the radius and taking the address, what the system is able to do is go to our GIS, or our graphical information system, pinpoint that specific address within the system, take the radius and look at the given area and look at a few examples of what's going on in that area. So in real time, once that address is put in, that call center agent or dispatcher will be able to understand any type of open SCADA or event detection system alerts or anomaly detection alerts within that radius that it's searching, any type of other open complaints that are also within that radius, any type of critical customers. So for example, if there is a large commercial client, a hospital or a dialysis treatment center or a stadium, what this will be able to do is increase the priority of the corresponding action, as well as understanding from the CMMS system if there are any planned or open work orders as well in the area. What this is able to do is increase the customer satisfaction because the agent in real time can provide more information back to the caller to reduce call recidivism, and at the same time it will reduce duplicitous work orders being entered in from that call center or dispatcher. What you can see in front of you is a very basic solution architecture of how the WaterWall interacts with the IT environment of a utility. If you're looking at the gray boxes at the top, which say external system, you can think of these as any current business systems, whether it be a CMMS, a workflow, a billing system, AMR systems, physical security, whatever business system is currently in place, the WaterWall system creates a plugin. And a plugin is a way to exchange data, either reading or writing, or pushing or pulling information from the business system to the WaterWall server, or from the WaterWall server back to the business system. And it first looks at validating the information, making sure that the syntax is correct, filtering this information, and creating specific objects so that the WaterWall system can speak in a unified language from each business system to be able to do that correlation. Once in the WaterWall server, there are handlers that are able to map the data into the database within that WaterWall server, help with the object transfer to specific WaterWall modules. And what is a module? It's of various types of applications, whether it be for digital standard operating procedures, for workflow processes, for analytics, that are stacked on top of the WaterWall server to gain additional functionality. Also within this WaterWall server are three important aspects of the system. The first being the statistical analysis, which we very lightly covered in scenario number 1. We're talking about early event detection, porting the real-time or continuous data from operational or hydraulic and mechanical sensors, as well as water quality sensors, and making sense out of that data in real time by both visualizing how the parameters are interacting amongst themselves, as well as on a statistical view, alerting to any anomalies. There's the geographic analysis, or the geo-processing, which we went over in scenario 3, which is specifically helping with making those geographic correlations, understanding the geocoding function within the database of the GIS system, and finding the object location and the placement of the various pieces of information that it's going to correlate. The rules engine is the function that enables the WaterWall to correlate the information. And what this does is it creates online rule execution for the real-time data and the discrete data by taking predefined rules. And who defines those rules? Those are defined by the utilities, processes, and procedures. So to create triggering mechanisms for workflow applications, or to create the brains that tell the system where to transfer information between, this is what the rules engine functions as. Lastly, and before we finish up, I just want to go over a few basic benefits of the WaterWall system. Mainly, the first one would be improving operational efficiency, being able to increase the transparency, accountability, and control over the entire utility. So having that holistic view, making sure that everybody is looking at it, understands how their actions affect other individuals, either externally or within the utility, and being able to track how those actions are affecting the utility and the time to respond to these actions. Retaining procedural knowledge through digitalization. We didn't touch on this, but with the application for workflow management, we're able to take standard operating procedures and digitalize those. So when any type of task that has a corresponding operating procedure is correlated or recognized by the system, individual operators or dispatchers will be able to have the information in front of them to react to that situation in a standard manner, or even automate areas of that reaction that the utility deems possible. Creating a single point of data entry with the ability to reduce redundancy. And this was really focusing on that second scenario that we touched on. The ability to map data entry points from business systems and those fragmented manual data and create those custom digital web forms so that data can be entered, validated, and then centralized and unified within that WaterWall server so that reporting can take place on data from throughout the utility. Being able to prioritize tasks and dynamically guide the response. Again, this is very much focused on the workflow aspect, which we didn't touch on. Providing insights into treatment and distribution operations. So we spoke about the analytical solution that's part of the WaterWall, being able to look at the hydraulic or diagnostic sensors or mechanical sensors and the water quality sensors together, and making sense out of the information in real time will be able to provide larger insights or deeper insights into how operations are actually affecting the goal of the utility to provide the high quality water, and looking at chlorine residual drop-off as it occurs throughout the distribution system so that operational improvements can be made. Being able to gain a big picture view of operations across the utility. This is really focusing on the GIS capabilities by reporting in information into the GIS from these various business systems, whether it's from the CMMS system with work orders, whether it's investigators that have arrived at scenes, whether it's customer complaints or specific customers that would like to be that you would like to notify. It provides on the GIS view an ability to look at the entire service network and zoom in, for example, to specific high service zones or low or high pressure zones. So it gives more of a holistic view of the utility operations. Automatic report population on both the compliance level and the managerial level. And this is very important because once that data mapping has occurred and you've created those custom forms and those are entered into the system, as templates are created for the specific reports, whether again it be lagoon reports, watershed reports, specific EPA reporting, managerial reporting, for example, looking at differences in shift operations or KPI reporting or key performance indicator reporting. Being able to have that information in one place and being able to click a few buttons to provide a report is a very useful tool to utilities. And lastly, being able to improve the real-time information to call center agents or dispatchers. And like we looked at on scenario 3, in real time, being able to provide more information and a better understanding of service disruptions or, let's say, taste or odor problems or issues that users are calling in about. For example, if it's a billing issue and understanding directly from the billing system and the AMR or the AMI system, if there's any type of irregularities, this can provide higher satisfaction for the customer and actually lower call return rates.